This video covers Stat 454, Chapter 7, Section 2, Initial Basic Feasible Solutions to Transportation Problems. In this first section, I'm going to demonstrate how to find initial basic feasible solutions using the northwest corner method. The basic premise is that we will use this simplex transportation tableau to identify, based on the constraints, the maximum value that can appear in each cell. Once we eliminate a cell, we will be done with the row or column, and we will continue in a northwest to southeast pattern, filling in as we go. So take a look at the northwest corner. The number that goes in this cell must be less than 2 and less than 5, or less than or equal to. There is one number that is both less than or equal to 2 and less than or equal to 5, and that number is 2. At least it's the largest one. So this 2 fills up the entirety of that column. Filling up the entirety of that column, I X that column out. I've used from the row's 5 spaces, I've used 2 of them, which means 3 remains. Now, if I'm traveling northwest to southeast, I either have to travel east or south. I can no longer travel south because that column is X'd out, so I have to travel east. I am now in this first row, second column cell. In this cell, I need a number that is less than or equal to 3 and less than or equal to 4. I believe 3 is the number that does it. That totally takes up that row and reduces this column's availability to 1. Now, similar idea, out of going east or south, I can no longer go east because this row is filled up. I must go south. Out of 1 and 1, the largest I can go is 1. Now, what I have here is a tie. Both of these quantities are maxed out. So I am free to choose whichever one I want to X out. I am going to X out the 1. I pick 1 to X out when there's a tie. That makes this quantity equal 0. I can no longer go south because that column is X'd out, so I must go east. The most out of 0 and 2 is 0. That X's out 0 and 2 remains. I can't go east because that row is X'd out, so I must go south. The most out of 2 and 3 is 2. That X's out 2 and reduces 3 by 1. And that makes this last quantity equal 1. So how would I write down this list of basic variables and non-basic variables? Well, first, the non-basic variables are the ones that have nothing in the cell at all. So that's x13 equals 0, x14 equals 0, x21 equals 0, x24 equals 0, x31 equals 0, and x32 equals 0. These are the empty cells, so they are all non-basic variables. Basic variables are the ones that have values in them. x11 equal 2, x12 equal 3, x22 equal 1, x23 equals 0, x33 equal 2, and x34 equal 1. A lot of students have an issue when they see this x23 equals 0 entry. They ask me, but Dr. Gilbo, I thought non-basic variables equaled 0 and basic variables didn't. And that is almost true. Non-basic variables are the variables we set to 0. What we're actually doing in this process, even though it doesn't look like it, is coming in and saying all of these blank cells must equal 0. We're determining a process that makes the blank cells 0. And that forces all of the other cells to take on values. And the values that they take on make them basic variables. So even though it's true that the non-basic variables must be 0, it's possible for the basic variables to equal 0. So this is how you find an initial basic feasible solution for a transportation problem using the northwest corner method. That ends content for part 1 of this section.